Today we have a reverse differential equation. Well, a bit of a change. So we have our solution, y equals cosine squared of x, and what we want to find is a homogeneous differential equation where the solution is y equals cosine squared x, kind of like the Jeopardy differential equations. So it's pretty simple to find the corresponding differential equation to this function that we have. All we need to do is we just need to take the annihilator of this function, and then from the annihilator we can derive the differential equation. So, well, there's a problem right here. There's no annihilator for cosine or sine raised to any power. But I do know that cosine squared x just happens to be the same thing as 1/2 plus 1/2 cosine 2x. And I know how to take the annihilator of constant, and I know how to take the annihilator of cosine raised to the first power of beta x, and in this case our beta is 2. So all we need to do is we're going to multiply our annihilator, since this is a sum of terms. Whenever you're adding or subtracting terms, and you're trying to find the annihilator, you have to multiply those annihilators. So I know that the annihilator of the constant is just d. And I know that the annihilator of cosine to the beta x, regardless of what if there's any constant, we don't have to worry about that, thankfully. I know that the annihilator of cosine or sine, in this case we're dealing with cosine, it's just going to be d squared plus beta squared. So I have d squared, our beta is 2, so beta squared is 4, so d squared plus 4. And now what I have to do is I just have to distribute this d throughout. So this is going to be equal to d cubed plus 4d. And this is our annihilator of the function y, and that's equal to 0, since we're looking for a homogeneous differential equation. And now all I have to do is distribute this y throughout. And what this d means is it's just the derivative of our function. And whatever d is raised to a power, it's just that derivative, that number derivative. So here we have d raised to the third power. That means I'm going to get y to the third derivative. And when I have 4d, I'm going to have 4 times y to the first derivative. So our question to our equation solution would just be y to the third derivative plus